Hello, everybody. So I will start my today's coding practice. So today's topic is this one: count of smaller numbers of the self. So yeah, let me get started. So given an integer array nums, return an integer array count where count I is the number of smaller element to the right of nums I. Okay. So the question is quite simple, and let me confirm my understanding. So I will go with the example which is given as an example one. So in this case, I will be given 5261. In this case, firstly, I will take a look at this number one. So there isn't any number to the right of this, so this should be zero. And for six, oh, I'm talking about the return array. Yeah. For number six, there is only one element in the right-hand side, and this one is smaller than six, so this should be one. I mean, there is only one smaller element to the right. And for two, there are two elements here, but there is only one smaller element, which is one, so I will wait one. And for five, there are three elements on the right-hand side, but the smaller ones are one and two, so this should be two. So I will return 2110. Okay, good. So that being said, okay, let me think of the algorithm. So the first approach, which I just come up with, is the brute force approach. So for each number, okay, so but let me just quickly confirm the constraint. So the return array should be at least one element according to the constraint, but it doesn't matter. If the given array is empty, then I can just return empty. And also, yeah. Okay, so I was saying, let me first say the brute force approach. So for the brute force approach is for each number, like this one, I will check all the right-hand side one and do the same for each element. So it should take n squared time because, yeah, for each element, I have to take a look at all other element. Yeah, on that right-hand side. And for space complexity, it should be constant aside from the one array to be returned. So let me tell you about the more optimized approach. So I have solved this question before, so and I actually don't have so much time today, so I don't, pretend that I see this question first time and struggle to solve this question. Yeah, simply saying there are three solutions I know for this. The first one, I use the segment tree, and the second one, I use a sorted array. And for the third approach, there is the merge sorted arrays approach. Yeah. So today I will skip this segment tree approach and start with sorted arrays approach, and then I will implement merge sort approach. I've never solved this question with merge sort approach, so the implementation of this would be the new for me. Yeah. Okay. So for the sorted arrays approach, what I do is quite simple. So I will use sorted list data structure. So sorted list data structure is something like sorted list internally holds the list in a kind of sorted manner. And what I can do with that is firstly push element into the sorted list, pop element from the sorted list, and then also I can know how many, I mean, how many smaller elements there are in the sorted list compared with the given number. So that's the basic, functionality of sorted list. So I will use it here. So okay, so what I will do is sorted list. Okay, and sorted list is internally has a tree structure. Even though it can be array-based structure, but I can think of it as a tree structure. The good thing is that when inserting into the sorted list, it will take all of log n time, and popping also log n, and also returning the number smaller element is also log n time, because I don't have to traverse all the element. I just have to go down past the, yeah. Oh, so we can think of it just like the binary search tree. I just have to go down the path according to the comparison with the current, I mean, number I'm looking for and the current position in the tree. So that's the sorted list. So what I can do is, okay, so with that sorted list, firstly, I will take a look at 5. Oh, I will go from this direction. So firstly, I will take out 1 because there is no element in the sorted list, it should be 0. And for 6, oh, and after that, I push this 1 into the sorted list. And then when I take a look at 6, I can easily say there is only one element smaller in log n time, and I get 1. And after that, I push 6 into the sorted list. Then I take a look at 2. I can say there is only one element which is smaller than 2, so this should take only log n time. Yeah, that works in this way. So it will take only n log n time. Good. Okay, so that's the, yeah, basically how I can solve this question with sorted list. So let me implement. So firstly, I will initiate the sorted list. So yeah, so there is a not standard, but yeah, Python package which has a sorted list. I will use it. So as I said, let's ever have the return array. And if I will take a look at numbers, in a reverse order, so I will iterate with the index. So the current number should be nums I. So first of all, what I can do is get the number of smaller element in the sorted list. I don't completely remember the interface of this, but probably I can use the bisect. That means I'm looking for the smaller element, not the equal element. Bisect right. So basically, bisect right works in this way. So this will return the first index, which is me internal list index is larger than given number. So yeah. So this is I mean, what is returned with the bisect right? So let me see with some example. So in this case, when nums I is say 2, this will return index 2. So which is exactly the same as the number of elements, smaller element in this array. So this is good. Yeah. And if I will give, say, 0, what happens is that first index which made nums. So even index 0 is larger than given 0. So it will return 0, which is exactly the count of elements smaller than 0 in this array. And just let me think of another case when 5 is called with. So in that case, no element, there is no element index, which means least index is more than given 5. So in that case, by the definition, this will return the length of the array, which is 6. So it is okay. So that being said, I will update the return array with smaller count. Then, as I said, I will append the current number to the sorted list, and then we return Steam. Okay, so let me double check my code and I will run it. So thing is sorted with, return is non times rank nums, and I will iterate from the tail of the list. Then I will get smaller count fast by using bytecode write compared with the current number, and then yeah, I put it in the return array, and then also I will add the current number to the thing. So there is. Okay, I will run code. Sorted with is not valid value for the expected return time. Oh, I have to return read. Good. But I missed one case. Let me think of it before seeing the test case again. So sorry, bisect right isn't this one. Bisect? No, bisect right isn't this one. Bisect right returns this condition, works with this condition. So when I try to do larger than equal to, I have to use bisect ref. Good. Okay, so my code is accepted. So let me work on the another solution, which is merge sort approach. Okay, so with this another approach, so I will think of it in this way. So I will split the array first to think of it. Okay. Yeah. First three, I will split it into 5, 6, and 1. Then I will split it into 5, and so 2. Yeah. So you can think of it as a kind of, yeah. Um, you know, yeah, kind of tree. Oh, this isn't tree, but it is. Yeah. Then I will go from bottom to up. So I swapped the order. So firstly, I have 5, 2, 6, 1, which are completely, separate one. And when I merge first three, I merge first three, 6 and 1. And what happens here is I will merge them in so that they are in the decreasing order. I mean descending order. And the interesting thing is that when I merge it, so I can know how many elements there are in the right hand side. So in this case, one can know this element, one can know there isn't any smaller element. And for six, when I merge six and one, I can know there is only one element which is smaller than six. Okay. And so if I do it right, say I add another two and then merge it in the say. Okay, now I'm telling you the bad example. So think of the approach where I add one more element here and then merge it again. So in this way, I can know how many elements there are, which is smaller than two and six. Oh, but because two isn't the left hand side, I just see number of elements smaller than okay, smaller numbers of two, but the answer of six is already fixed. So I just merge it just to know how many smaller elements there are for two. And then I get five. I merge and sort it. Then it looks like this. 126 is already has answer. So for five, I just can calculate. However, this approach takes n squared time because I have to add one element n times. And for each time, I have to do the merging merge sorted list. So in total, it should be n time, and it will be n squared. So instead of that, I'll use the kind of divide and conquer approach. So firstly, I did this one, and also I will do it for 5 and 2. So when I do this, it should be 2 instead of 5. However, because 5, even so, oh, sorry. Oh, let me just swap these numbers to make it more interesting. Yeah, in this way, so when I merge these two numbers, it should be 5 and then 2. So even though it seems like 5 has one small element, 2, it isn't the case because 2 was originally in the left-hand side. So when I do this, only right-hand side, no, left-hand side can count the smaller right-hand side merged sorted list. But for the left-hand side, even though which number comes, maybe smaller number comes in the right sorted array, it cannot, it doesn't increase the number of smaller element for the element in the right merged, right sorted list. So this approach, there's a key. So let me just say, I will start with 0, 0, 0, 0. Yeah. And let me see. 2, 5, 6, 1. Firstly, I merge these, and what happens is that because 6 is on the left-hand side and it finds one element, you will append this. So I will write this because this is yeah. So for 5, 2, when I merge these arrays, what happens is that they are merged into 2, 5, and it turns out that the 5 has one number which is smaller. However, it is in the right hand side, so the return arrow is not updated. And then I will merge 5, 2 and 6, 1. So when I merge it, it becomes like this. So originally this was it. It should be 1, 2, 5, 6. Yeah. So when I merge it, I can simply say, oh, so when I merge, yeah, in the process merging, I can say, for example, 1, it finds no any smaller element. And for 6, it finds 3 smaller element. And out of them, 2 are from the right sorted list. However, I cannot update 6 because they did the right list. However, for 2 and 5, they're in the left-hand side. So when I do 2, it finds one new element which is smaller, so this should be 1. Originally, this should be here, so 1. And for 5, it finds a new smaller element which is 1, so return arrow should be updated in this way. Okay, so wait a minute. So that's a basic approach. However, I'm thinking how I can simplify the implementation. So mhm. Wait a minute. So when I merge 6 and 1, I should already count. Yeah, so the what I can say is, so when this was 2, no, 6, 1. Okay, so when merging, only for the element in the left hand side, it will count and update the smaller count. But if it is in the right sorted list, it doesn't update the return array. So I think it works. So for example, even though if when I merge first 3, 5, and 2, and when 2 is, for example, updated, then when I also merge with 2, 5, 6, 5, 2, 1, so I'm just thinking of one case which is a bit annoying. Let me write it. So I'm just wondering if I merge this and this. Okay, right. So I just wanted to confirm if I always update the left-hand side array when merging, just by seeing the count of element in the resulting merge sorted list. However, it doesn't work because in this case, 2, 5, for 5, 2 is on the left-hand side. But here, they are in the same array. And when merging with 6, 1 array, 5 can find 2 smaller elements. However, 2 is already, I mean, originally it was on the left-hand side, so it shouldn't be counted. Okay. So I think this approach works. So increment the return count, number of smaller element count when merging, only if left count, only for, increment by the count of smaller element in the left-hand side array. Okay, so let me work on the implementation. Oh, and the time complexity of this algorithm would be NlogN, because in this is a kind of divide and conquer approach, and I split the array into half all the time. So it would take, so okay, I can say originally if it has say 8 element, it should be divided into 4, 4, then 2, 2, 2, 2. Then 1, 1, 1, 1. So I can say you can find the sum of these of 8, 8, the whole array, 8, 8, and the number of this 8 is exactly log n. Yeah, with base 2. So it should be n times log n is n log n time. That's the basic idea of divide and conquer approach. Okay. And first case complexity, it will take log n for the recursion stack. Yeah, because the recursion could be as long as log n depths. And also for when there, in each of the recursive function, it will take n, space, because I have to keep build and use merge sorted list. Sorted list, which could be up to n. Okay, so let me work on the implementation. So first we ever this return array. And I will work on the divide and conquer. So instead of passing around, no, yeah, okay, sorry. So yeah, so this is the basic idea, and what I can do is firstly, if ranks of num is 1, then I will just return none. Or actually, this method does two things. Firstly, return the sorted array, and also increment set of answer. Yeah. update self.answer. You can say, yeah. So if there's only one element, I just return the array as it is. Okay. And if there are more than two elements, so what I can do is left half. Okay, so number left half should be nums divided by 2. So I can decide it, but I will do so. So firstly, I will call count with so I split the array into 2 and then I will get merge, I will get sorted rest. Then here I will merge it. So country, I will make this name descriptive. So what I should do is uh, let me say Li and Ri. So this is start index. I will keep doing until both of them are still in the valid range. If left eye is already into 1, I start with I pick up right number. Okay. And because I choose the right number, I will append this. And if right element is already finished, right array is already, all of them are already seen. Yep, that's it. So, otherwise, I will pick a smaller number. So, okay, so if Okay, so in this way, I do merge sorted list. So if right element is smaller, then I should pick the right one. So I picked the right one, and also smaller count is already also updated. When they are equal, I will choose the left one. The key point here is that I always would try to pick the left one first, because in that way, when I append, oh, I actually don't know where this index already was first. Let me write this in the code. So, so if I always try to avoid that right element, originally right element comes after originally left element, if there is the same number. Wait, so it doesn't work. Wait, so I'm saying something opposite. So right element is, yes, yeah. Okay, so those are average correct. So if the right element is smaller than left element, then right should come first. However, when right and left are the same, and when I pick the right first, yeah, in that case, that one is, no, it's confusing. I will just, yeah. Yeah, so I think yeah, I decided to change the, I mean, condition because it will be confusing. So if left and right is the same, but if left is larger, then I can pick right, and smaller. Wait, so no. I even in this case I have to add it. So when there's the same, let me write left. When there's the same, I can pick either, but if I pick the right element, so what I'm thinking of, so I'm a bit confused. Let me write it down. So when I think hub 433, and so let me think this is a left. In this case, I can pick either. No, I should always pick the left one first because this right one shouldn't be included into the count. Okay, so when I said when there's the same, I should pick left first. So I mean, if left element is equal to right element, or left element is smaller, I should pick left first. Yeah. And otherwise, I pick the right element and then what should I do? I pick the right element and I will increment smaller count from right. And where I should do it? Here. Yeah. And also I have to do this. Okay. Then I will return read. So one improvement here is I have to get the original index of this element. So how can I do it? So probably what I can do is here. Okay, so I will create an array which includes index. So I can do it in this way. So here, this num should be tuple of original index to number. Yeah. So what I can do is this. So and this will be necessary to take a look when I access it. So here in line 80, I think it doesn't matter yet. But when I compare this and this, yeah, I have to take a look at the, index one, and then appending here is okay. And here, instead of this, I will take a look at this. So this is the original index of the current left array element. Okay, so I think this works. So let me confirm and walk through my code. So as I said, I will build the answer array first, which is 0. And also I will call the recursive function count with list of tuple index and num. And after counting all of them, I will return self-output answer. Okay. So in line 66, I worked on the base case where there's only one element in the array. In that case, I just have to return the array as it is. And for from line 69, I will do the typical merge sorted list. So left index, yeah, this is the end of left half. And then, oh, wait a minute. So is it really okay? If the number of element is 2, the n should be 0. If number of element is 3, it should end with 0 or 1. So let me think, if there is 2 element, it should be 1. Maybe this should be the 1. And if number of element is 3, it should be this left index with 0, which is okay. If length of element is 4, this should be 4 divided 2 is 2 minus 1 is 1. It's okay because index 0 and 1, there are 2 elements which are half of 4. Okay, so left hand and right half should be like this. So first I call the recursive function to get the sorted list. Okay, then I will have return array. Let me rename this to merged. Then here in line 78, 79, if left sorted list is already finished, I just take a look at the right element. And if right in line 83, when right sorted list is already finished, I will take a look at left sorted list. And then if they are still remaining, both of them are remaining, if left is smaller than right, or if they have the same number, I will pick left. And so in this case, I will append, I don't know, the left element to the sorted list, return merged list, and also updates the original answer of the original index by 1. And I will decrement Ly. Okay. And in line 94, when I pick the, say, number 3, or maybe like number 2, I add the number 2 to the merged array, return merged array, and then smaller count from right will be incremented by 1. And right element is no. I will take a look at smaller index. Yeah. In right merged sorted ref. In right sorted ref. And then return merged. Okay, let me run code. Oh, sorry. So in this case, when after choosing the right, I have to decrement it. Okay, so I mean it doesn't work. I just want to see quickly if this is split in the correct way. Because I have struggled here. Oh, wait, so it's split in the correct way, I guess. No, 2, 6, 3, 1. Okay. 1, 2. Wait, so left, right. seems, oh, and it is already sorted. So now, I mean, the second element should be sorted, so it's okay. Hmm. So firstly, taking a look at this output. Output is always sometimes smaller than expected and sometimes larger than expected. And in case of this is completely smaller than expected. But maybe when we take a look at this, because I can debug it more easily with smaller element. So when I split it into this, so in my algorithm, I will start with 0, 0, and because here is the same in line 93, merged, append left. So left one is picked first. So 0 is picked first. No, yeah, this one was picked first. No, this should be smaller count from right. So yeah, obviously I have to, increment the answer array with the number of smaller elements which come from right array and smaller than current number. Oh, so this for this one is okay. Never take a look at this one. So somehow, I mean, the returned array is not updated at all. So let me see. I'm just curious if this is a need. I just want to see if smaller count is always 0 or, I mean, a smaller count from right is always 0 and it's a problem, or this part isn't reached at all. So I just want to confirm. Wait a minute, so seems like this is updated only once, which is strange because according to the answer, I have to update more at least 3 times. So for example, when this and this is merged, this part is not reached at all. So how should I debug it? So wait a minute, so I'm thinking, okay, so this is original index and this is the value, so 0512, okay. So in this case, so in this case, this should be picked first from left array. No, this should be picked first. Yeah. So left, when they, the smaller element should be picked first. Oh, I think it opposite. So when these are when this is smaller, left, when right element is smaller, right should be picked. Okay, when left element is smaller, like this one should be picked first. Yeah. Okay, so what's the problem here? So I'm thinking of the case when index is 0 and value is 5. Index is 1 and value is 2. In this case, the right one should be picked first. So it's okay. 2, 5 order. Yeah. And when take a look at 1 and 6, they should be in the same order. And oh, the problem here is I should increment 6, element with by 1 because it has found one element smaller than 6. Okay, so actually the problem is 2631. Okay, so in this case, this right should be picked first. Here, and small count from right should be incremented by 1. It's okay. And right in Ri should be -1. And here, after the next, iteration step in 185, it should be. So when I pick this one here, I should do this again, like I did in 199. Then I can decrement left index and so on. Okay, so I'm approaching, I think. So the problem here is about the 5 and 2. Let me write it here. 0, 5, 1, 2. Wait, in this case, in this case, this should come first. Then index 0, this one should be incremented by 1, which is okay. And for 2, 6, and 3, 1. Okay. This one should be picked first. Then it comes this one next. So index 2, this one should be incremented by 1. Yes, okay. Then in this case, firstly, when this array is given, I get this left half array and this right half array, which is okay, I think. No, this isn't okay. Why this is not sorted? Hmm. Wait a minute. So this is not sorted. Why is it 3, 1, 2, 6? When it's a smaller element should be picked already, always first. So in this case, hmm, let me just rename this self.count with self.merged. So probably the merging up. Oh, the problem here is I append the element from top to the merged list. I have to reverse it. Ah, okay. 0, 5, 1, 2. Okay, so let me take a break because I have to do something from now, but I will come back and resume the video after coming back. Okay, I'll come back. I have more time. So when firstly when this and this, I mean this and this, hmm, 0, 0, 5, 1, 2. So here, index 1, which means this, is incremented by 2. Is it possible? No, because 6 is larger than 2, so only this element should be picked. But somehow this one is also picked before this one is picked. Wait. This is quite, carrot thing. So this should be an error, you know. Okay. Okay, I will run my code. Good. I have to delete this previous statement. Okay. Okay, so my solution is accepted. So I finished my today's practice. Okay, so yeah, I will quickly wrap up. So in this question, I came up with three solutions. The first one is segment tree approach. I skipped it. And the second approach is using the sorted list. So sorted list is a standard Python library, which internally is like a tree structure. So with the powers that it can do most of the operation in n, I mean O-log time, I could implement it in n-log time, which is good. And also for the third approach, I use the merge sorted list algorithm. So in this approach, I use the kind of divide and conquer and do the merging sorted list in each recursive function. And in the process, I could count how many elements are in the right-hand side and smaller than the current element. Yeah. So I made a few mistakes in the process of implementing the merging sorted list here. Yeah. But basically it's the way how it works. So it takes also n-log time thanks to the recursive function. Okay, so I will finish my today's coding practice. So see you tomorrow. Bye.